I feel this is a good time to go ahead and finish off for the day. So, I've recently been messing around with the whole idea of, okay, so I'll just go through it here. This is another growth sequence. This is of something that uses what I'm calling parameters. They're just a sort of plan that uses a function that tells you how to change certain parameters in the cells, including the tips and in the radial cells that you might want to change over time. So these ones uses a sine function, and I noticed that I started to get something that looked like a flower out of that. And so up until now, everything that I've done has had a very serious self-similarity, because the parameters don't change over iterations. So now I have parameters that change over iterations, causing the cells to differentiate and form into different forms. This little one here is sort of the first one that I've got that kind of has something that resembles leaves, the way that they're all folded up like that. I'm having a problem right now, just trying to get it to continue forward with this, because of an error that I haven't fixed. It's been around since earlier today. But look at that pretty cool trunk structure. It's like this little plus that just goes around, and then it sort of ends up like that up here, right? But it gets into these other weird knobby things which aren't part of the actual function. Like, all it's telling, the only thing that's happening here is that these little guys are getting growth. They're getting, what's the word? They're basically just getting something that's telling them to grow in a fashion that is somewhat like this, but not completely. Like, they do react to each other. So this is where there's a difference between what the cells actually do and what they come to represent. So once these cells start to go through this differentiation, they have a couple of different things that are telling them what to do. They've got their growth rate. Here we go. Let's go over here to the scripting, and you can see. So I've started to do everything in this parameter class, and the parameter class is just this. It shows basically, we have a frequency here and a couple of other things. I can set a parameter that is set actually inside of a cell. There's still some things that are not set completely, and I haven't messed with these things yet, but age can't be set, but ease and ease away, things like that, those two things will be, and also min distance, those things will be very interesting to play with, because those change how the cells actually move around in comparison to each other. they're already getting some like growth functions. So some of the cells are faster than the other cells. I'd like to see how this turns out once it just keeps growing, but yeah. There's also a thing that I just as future notes. I want to see if I can get the system to tell me how to, like, I need to do something like, sorry, I'm just looking at this and it's just it's a trip because it makes these really cool open flowy patterns here. If those can open. But yeah, if I can get this thing to show me what happens to the tree after it's 20, I could probably get some interesting information. I've got some pretty good ideas in as far as like allowing the cells to move also, all of them to move at the same time. For instance, to adjust specifically a branch that's already been grown to some position or whatever. This could actually lead to a completely moving system that moves over time or whatever compared to one of these functions. These are the functions that control the parameters. Like down here, the code's getting a little bit long, but yeah. Down here we've got a random seed is GrowF now. That's what the project is now called, GrowF. And so what we have over here is the parameterization of the bifurcation parameters. That's a tuple with like 8 things. And then the radius and x and y growth matrices. So what I'm going to be doing is I still have to consolidate this into the tree class, but the tree class is up here somewhere. Anyway, I still have to consolidate that, but I'm going to be consolidating all of these things, right? And then pretty much all of these things which you see as hard-coded numbers, all of those are going to be replaced by numbers that are chosen by a genetic algorithm. And these hard-coded numbers and these specific tuples and a couple of other things like cell growth, all of the stuff that becomes parameters, those are all just going to go into this DNA object up here and as the data. And then the DNA object is just going to be the one that's responsible for like moving, I don't know, doing for instance, if you want to do some mutations on the growth pattern for an organism, then basically you just have to go in here and change. I mean, you don't have to do anything. The system will automatically do it, but these things will be part of the DNA, and I'll just be setting it up like that. So there's some refactoring to do, but I'm just getting a hang of the functions and stuff like that. Another plan that I have is I'm going to be taking the functions and I'm going to be pushing them towards being able to be in lists, and also taking it, instead of doing like min and max and a function, having it set up so that I can just have a list and a function, so that the function can do like an index, random index, things like that, right? Anyway, so pretty much what the DNA is going to be doing is like creating random parameters for all of the mins, max, and starting values for all of the parameters that are listed here. And that's going to allow the system to increment stuff one way or the other so that it can slowly increment an organism towards some specific goal that it needs to do. And by the way that the cells are going to be moving is that there is still that center cell on everything, right? Right now it's completely unconnected, and these guys are also still unconnected. Like, but what they should be is connected to that center cell down here, and all of the center cells in the slice. Like, the slice just needs to have a thing that represents it as a cell, and then the slices can move together, and as the slices move, the cells move. So I'm going to have to be setting up the cell locations as a relative location to their slice, and then every time that a mesh is created, that calculation would need to be done, or I could do it the opposite way. But yeah, that's how, I don't know, that's how that kind of works. So I'm really interested in figuring out, like, what kind of combinations and what curves I can do to make, because there's two different things that I've been seeing. One is that the genetic algorithm can choose randomly how to build a tree, and it can go tree by tree in a specific environment, like the tree by itself or whatever, and just testing of, remember, this is not like the full-on tree. I still have the kernel, the seed, everything like that that's in this code, updates on GitHub. But the thing about this is that there's going to be a seed down here at the bottom, and that seed is going to be just like a couple of cells. The amount of cells that are this, it's going to be represented at first by like some sort of a cells like that represent, like, obviously, because we're going with the motif here for seeds, so when you haven't planted the seed, I still have to do the roots, but that's coming. It's going to be great, though. I've learned a lot now, so roots are coming, and they're going to be just as smart as the top part. So yeah, basically when this system needs to differentiate, it can differentiate. I also had an idea. Okay, so like these are those growth plans, basically, right? So everything can move beyond its growth plans, but there can be like certain things that happen. For instance, like there could be an oscillation that happens in a branch or something. Like, that's why I have these different sine functions, the sinusoidal functions, the spike and bump functions. This is using bump, and bump is just an ABS sin, right? ABS sinusoidal, and spike is the contrary. It's one minus that. But anyway, though, that's what I've done today and this weekend, and I did have some time off yesterday, but yesterday I did get a lot done as well. So I'm thinking that I can go ahead and call this like pretty much good for now. Any questions or comments, just let me know. Please leave a like in the video. And if you're excited about making some tree NFTs, and I think that we can, this can definitely become something that really works out well. And with help of the genetic algorithm, I'm definitely going to be able to like breed stuff better. Like, I'm going to try to figure out the best parameters to do, because all of these are sort of just like, either the random curves, because a lot of stuff is random right now, right? The entire bifurcation stuff, I've got it all as random, just so that it comes up with something. But as you can see, if I just like delete this, I can delete this just fine, because technically the parameters are saved. So sorry, this is the actual, like, what it looks like. I could make it, hold on, let's see if I can just, what happens if I give it more cells? The randomness is going to change a lot. It's going to become a completely different plant if I give it more cells. So check this out. I give it, we'll give it double the cells. 48 cells in that's the cell resolution for each slice. Also, this is going to be parameterized. And it can also be a parameter that changes over time, just like all of these. Yep, there we go. Completely different. Like, it's using the same bumpy parameters and stuff like that. So, besides some things, but yeah. Yeah, this one's got some weird spiky things going on. So, obviously, things that are based on randomness are really great for stuff where it's going to be the same type of setup over these parameters. So, also I was talking about those curves, right? So like the curves are just the parameters in those functions. So those functions are different. One's a random curve, this one's a log curve, all that stuff, right? The other one's just like a ratio curve, so you can do it by whatever you set the frequency as. And there are many things that are based off of these parameters. So if we look up here in the cell, okay, nothing is a parameter, right? But in the slice, I've got a couple parameters, the rate, growth, radial, and that's hard-coded right now, but that also needs to be, I need to be able to access that from the main make function. And then, yeah, I think after that, after this, I'm gonna get the root functions going. It needs to be able to find nutrients and stuff, though. Otherwise, like, there's no reason for roots. So I'm gonna have to get the hormone system going, but I'm also gonna have to get then the nutrient system going and the cell network. So the first thing is to connect those cells up properly so that they can send information back and forth to each other. I've also got a give function. There's nothing in there yet, but it's an amount of hormone. That's going to be something that I think will eventually be maybe just give. It could be something else beyond give, but I don't know. What you were seeing before is all you have to do is add a subdivision surface on this in Blender, and you can make it look nice and smooth. I mean, this guy is a completely different beast. His use of whatever that stuff is. So I can also, okay, so basically, like, if I change something up on bifurcation, there are certain things that I change on bifurcation down here. So bifurc is the thing that's being used and passed to the chute, right? And I get the p-tuple next of the b params right there for bifurcation and the starting radius information. So these two things, and when I feed them into the chute, when a new chute is made on the bifurcation. So obviously, if you were to take these cells and then put them in a different situation where you aren't, like, you have to think of this as like the lattice that's being set up for these cells to grow on. And then the cells just grow on like this lattice or whatever, and there's two different types of cells. But technically you could have one type of cell that can just make new cells, and whatnot. The thing is that until they have to fight for or resources or work together for resources, and have reasons to do that over their lifetime, like in an ecosystem, then there's no reason for them to differentiate, really. Like, I'd still think that I need to make some little intelligent slightly intelligent bees or like little flying things that go around. So like I could put together some just basic AI like fauna that would go in and do things for these plants, like basically create a symbiotic relationship with them. But for now, I'm like I said, I'm just really trying to get how this system, like how I can get as many of the parameters and all of the parameters, like I can maximize all of the different things that you can see if you just grow these without any external, you know, they basically, I don't know if I said this earlier, but these are like crystalline structures right now. You know, I've got that grow sequence over there, and I've got another one. These are oh, okay, this is the last thing I wanted to talk about actually. This one here is, all I did was change the random seed. Okay, this is the same exact parameterization, and if you see like the branching and stuff like that is even kind of, yeah. Oh, okay, I'm sorry, the branching wasn't parameterized at this point, right? So this is just an example of like how different things in like in a multiverse, because you have to think of the random seed as like basically the name of a different multiverse, right? And the name of that multiverse changes the randomness, any of the randomness that happens in that multiverse. So all of the chance coincidences as this thing is growing during its steps. In this case, the only thing that it did was was change the tip speed randomly within a certain amount. And this, okay, so this one was really cool because it kind of started looking like buds, or I don't know, asparagus, who knows. Growing some asparagus, growing some virtual asparagus. But this one started looking more like some sort of a weird tree thing with like extra little antlers pointing out up there. And that's not an actual randomness in branching, it is only randomness in the speeds of how each of these went. So it's kind of like this is the same tree, except in two completely different worlds. In this world, some other shit happened. Who knows? It was random. Like literally, I mean, we could look at the seed of the random thing and figure out what this does. But yes, something else happened there, and so on and so forth. Anyway, this thing never stopped growing. I wanted it to stop growing, but the randomness didn't want it to stop growing, right? So if you have physics involved in this, and these actually are figuring out stuff about light, and they have to live together, like, I don't know how much, how much of this can actually happen or whatever, how many of these can run at the same time. If all of them were to do time steps at the same time, it would start to get really complex, because so just on this last one that I did here, this guy, our little weird looking doodah here, yeah, he's only got 24 tips, and he's only got 6,288 cells, which are all the vertices in this thing. And remember, he's nice and smoothed right now. But some of these plants have like 300,000 cells or 500,000 cells, things like that, because of how that all happens. So the more that I can actually get this code, like the code itself. That's because basically all of this stuff is removable from the actual interface. I can take all of it out of Blender, and I can write it all in C++ if I have to. I don't want to have to, but if I have to, I'll do it just so that I can use like proper GPU oof, like, I'm not even gonna make a Windows DLL. Screw that. I might, but anyway, though, the cool thing about this whole thing is just that I finally reached a point where I think I'm getting close to like leaves or something like that, and just how what control this has over everything. It even can squash things on the XY axis before it gets rotated up all the points. So into the direction of the growth. So like basically, yeah, leaves are totally possible within this makeup. Either A, at this point, like either A, I can try and find them, or B, I can try and figure out how to get a genetic algorithm to do it. But in order to do that, I need to have these things over many lifetimes, and multiple of them compete for space and light, and try out different crap against each other and see what gains. The only thing though is the roots. I gotta get all that root stuff working first, and I've been reading this book. So yeah, I've been learning about the communication between cells, and I want each of the cells to have like an oscillator that starts out when they're born, and hopefully what we can see is that the oscillators sync up somehow, or we can get them to sync, we can force them to sync up somehow, right? And these little oscillators. And I think trees are like 200 hertz or something like that, but I mean, really, those oscillators, they could technically be used for anything. And I was also thinking that the cells themselves can literally be used for, like, the cell can have its own little neural network, just like in that other YouTube video that I really love. But anyway, enough for now, and yeah, next time we'll have better stuff.